Okay, guys. So we've managed to investigate the angle at the center using two different scenarios, and we've managed to prove that the angle at the center and the angle at the circumference have a relationship where the angle at the center is twice the angle at the circumference, and we've proved it algebraically. So now we we have seen in the first video that uh, the relationship holds whenever you move the angle at the circumference. It stays the same, right? But now something happens when now the angle is below. There's no more a relationship. If you look at it, the angle now at the circumference, which is C, is now bigger than the angle at the center. Now, if you're wondering what is happening, this video is exactly for that. So I just want to make the circle bigger now. Let me just make the circle bigger. Let me make, and I want to move it away. Let me select the chord and move it away and make it bigger. Okay, so it's bigger nyana, and I want to move the chord somewhere else. Let me just move somewhere else so that I can create space. Now it's too big. Wow. Okay, fine. So the angle at the circumference now is 119, and the angle at the center is 121. So there's not much of a relationship, and if you multiply, there's nothing here happening. So now if you're wondering what is going on here, so now I just want to show you the relationship has changed now. If we would calculate the angle here now, here's the angle here, maybe a different color. Let me just use red. Fine. So we have two angles here. We have the red angle and the gray angle. The gray angle is angle D, and it's 121 degrees. And we haven't measured the angle that is red, but we can. So I'm just gonna go to my calculator here and calculate. And remember, let me just move my calculator here. This angle is a revolution, meaning both of them add up to 360, right? And angle D is 121. So what I want to do now, I want to subtract uh, this angle from 360. I want to subtract the angle from 360. So it means I have 360 minus the angle at D. And now all of a sudden 360 minus the angle at D is equal to twice this angle. So now the angle at the center and the angle at the circumference are different now. So if we look at the angle at the center, if it's an acute angle, it's going to be equal to the one that is below here, and that is an acute angle, right? Acute angle. And then if it becomes more than an acute angle now and becomes an obtuse, is equal to the angle that is red, that is equal to half the angle that is red. So now the relationship of the angle at the center and the angle at the circumference changes when the angle at the circumference is acute and when the angle at the circumference is obtuse. So if you look at this here, This is an acute angle. It's less than 90 degrees acute angle, right? So now it's equal, it's the angle at the center. This is the angle at the center, which is the pink angle, is twice the angle at the circumference, right? But immediately when the angle is obtuse now more than 90 degrees, then now the angle at the center will be this one labeled in pink. So the next video is going to be how to prove that using algebra. Thanks for watching. Do comment, like, and subscribe.